Hello and Assalamualaikum. Welcome back to another video. Today we'll delve into the practical application of SmartPLS4, a statistical modeling technique primarily employed in the field of structural equation modeling. This application stands out for its user-friendly interface and is particularly valuable for certain research scenarios. Now let us dive into the model we'll be exploring today. Our study aims to gauge risk tolerance by considering various factors including investment awareness, financial technology, financial experience, and financial knowledge. Additionally, we delve into the influence of neurofinance, considering the psychological aspects like loss aversion, pleasure seeking, and representative heuristics. This is the dataset. In totality, we have 204 responses which were gathered from students of semester 6, semester 8 and postgraduate possessing a strong financial knowledge and background. Previously validated scales were adopted to quantify the variables using questionnaire with responses measured on a 5-point Likert scale varying from 1 representing strongly disagree to 5 representing strongly agree. I have renamed the questions for my ease, like risk tolerance 1, risk tolerance 2, risk tolerance 3. Same is the case with all the other variables. Now let us start from the scratch. In SmartPLS tab, go to New Project and name it. Now we have to import the data file. You have different options of scale available. You can select any based on your research. In my case it is ordinal. Then minimum value I have is 5 and the maximum value I have is of 5. Minimum I have is 1 and the maximum I have is of 5. Now this represents the descriptive statistics including mean, median, observed minimum, observed maximum, standard deviation, kurtosis, skewness. Next we can see the correlations also. Now we have to create the model. You have to select the model type, which is PLSM, and you can name it. Now we have to create a model. To do this, simply double click on the blank screen and a new latent variable will be generated. You have to rename it and have to create the same model as shown in this picture. So first we have investment awareness. Second, we have financial technology. Third variable is financial experience. Fourth, we have is financial knowledge. Our dependent is risk tolerance. Representative heuristic is our mediator. First moderator we have is pleasure seeking. And second we have is loss aversion. Now you have to add the indicators. For our first variable, for our first variable investment awareness, we have two indicators. For financial technology, we have 4 indicators. For financial experience, we have 1 indicator. For financial knowledge, we have 4 indicators. You can also shift the direction of these indicators by clicking here. For risk tolerance, we have 3 indicators. For loss aversion, we have 2 indicators. For pleasure seeking, we have 4. And lastly, for representative heuristic, we have 4. Now you have to connect these variables by using this option, investment awareness to risk tolerance, financial technology, financial experience, and financial knowledge. Next, we have representative heuristic as a mediator, so we'll add arrows from here as well. And then you have to connect representative heuristic to risk tolerance. I'll move move the direction of indicators upward. Okay, so pleasure seeking and loss aversion we have are as moderators, so we'll add the moderating effect, this arrow to the middle of this arrow. Same is the case with loss aversion. This is the final model. Now the first step is to calculate the PLSM algorithm. PLSM algorithm basically serves as the core method for conducting structural equation modeling. Using partial least square, it enables the researchers to create and test path models illustrating a direct and indirect relationship between the variables. We'll come to the graphical output later. First we'll see we have the path coefficients of risk tolerance here with all the other variables. Next we have the indirect effects, the total effects, and then the outer loadings. The outer loadings basically indicates the correlation between indicator and the estimated latent variable score. The value should be greater than 0.70 as shown in this table. All the values are in green, which indicates reliability. Next we have different other options available too of outer weights, latent variables, the residuals, and simple slope analysis in a graphical form. Next we have to assess the model fit using the quality criteria. We have R-square here. The R-square of our model is 0.344 and the adjusted R-square accounts to 0.310. Next we have the F-square. Construct reliability and validity are crucial. Reliability measures the consistency of results from an assessment tool, while validity assesses whether the construct measures what it is supposed to. Based on the composite reliability and AVE value, we conclude that our variables are reliable and consistent. Next we have some graphical representations also drawn by alpha. This rate is basically showing that the values were below threshold, but on the basis of AVE and composite reliability we can conclude the validity. The next we have the discriminant validity. Discriminant validity basically indicates how unrelated items of one construct are to the items of other latent constructs. We recommend using the HT-MT criteria. If the values are below 0.90, discriminant validity is well established, as you can see here. Only one value is greater than 0.90, which is in red, depicting a troublesome value. Next we have collinearity statistics, which represents that the value are less than 5, and multicollinearity is not an evident problem here. Next, the model fit is assessed. In model fit table, we only recommend using SRMR ratio and NFI. The value of SRMR should be between 0 to 1 as in our case, and the value of NFI should be close to 1. So it is representing that our model is well fit. Next we have model selection criteria and all the other options. Now coming back to the graphical output. In graphical output we have different options. We can choose as per our requirements. Like in the outer model you can either keep it blank, either you can display the outer loadings, outer weights, or both. Similarly, in constructs you can either mention the AVE value or the composite reliability or the R-square or the Cronbach alpha. It is totally up to you. In the inner model you also have different options like correlation, covariance, indirect path, path coefficients, total effects, or F-square. So this is it from the PLSM algorithm. The next step we'll be doing is PLSM bootstrapping. For PLSM bootstrapping, you go back to Edit, Calculate, Bootstrapping. The significance value is set to 0.05. You can also change it to 10% or even 1%. PLSM algorithm basically is used to estimate the path coefficients. The report will typically take 30 seconds because the dataset is having large number of observations. We'll come to the graphical afterwards. First, we have the path coefficients. Here we can observe the coefficients along with the p-values to determine whether our hypothesis has been accepted or rejected. The red color is showing non-significance while the green color is showing the significant values. We can see that financial knowledge is significantly related with representative heuristic, but financial experience is not significantly related with risk tolerance or representative heuristic. Next, we have the specific and indirect effects. Specific indirect effects is basically showing no mediation because the p-values are in red and are greater than 0.05. It means that representative heuristic is not acting as a mediator between an independent and dependent variable. Next, we have total effects, auto loadings, auto weights. Okay, now in histograms we can customize the graphical representation as per our preferences. We have path coefficient histogram of all the variables we can see here. Next, we have the indirect effect histogram, the total effect histogram, and the auto weights histogram. Now moving back to the graphical output, we can customize it as per our requirements. Like in the auto model, again we have different options of displaying only the p-values, the t-values, or auto weights with p-values, or auto weights or loadings with t-values. In the construct, we can see R-square, ABE, composite liability, Cronbach, or adjusted R-square. Similarly, in inner model, we have different options of path coefficients and p-values or path coefficients on t-values. One of the option we have is of the highlight path. Basically, we can highlight the specific path using the relative values. The darker and the thicker arrow is showing that this is having the most significant relationship, followed by the financial technology and then the financial experience. That concludes today's video. I hope you found it informative and helpful. Do not forget to like, comment, and subscribe to our channel. Thank you for tuning in.